If two graphs intersect and create a closed region, how can we find the area between them? So that's kind of what we're talking about in this section. And this is really just extending the idea of the integral that you learned at the end of Calculus 1. And so it's not going to be too much more than what we've been doing and what you already know how to do. So let's look at this motivating example here. So we have this region S. This region S is bounded in the x direction, or on the x-axis, between A and B. And then it's bounded by the curve f of x and the curve g of x. And so we want to find out what is the area between all these. And if we go back to what we learned about integrals in Calculus 1, we can take strips of a certain length, so a delta x length strip, and find the height of the strip. And then once we do this over the entire area that we are interested in, we can get an approximation of the area. And then, of course, we can take the limit as n goes to infinity for the number of strips that we're looking at, and then that will give us the area under or between these two curves. So if you remember from Calculus 1, the width is always the same, and then the height in Calculus 1 would go from the x-axis up to the function value. In this case, we need to go beyond the x-axis, and it's also possible that this entire region could be above the x-axis. That would not change anything. And we'll see that in a minute. In this case, we're going to add some below the x-axis, and so that's also the value of this function, g. And you also notice that we have negative g of x, so g of x of I. And so how does that play in? Well, when we look at a formula, the area A between two curves, f of x and g of x, and then the vertical lines x equals a and x equals b. Of course, f and g are continuous. We're going to assume here that f is always greater than g, or equal. So f is always going to be above the g curve. For all x in this interval a to b, then the area is given by the integral from a to b, f of x minus g of x. So if we look at this picture down here, here we have a picture where g is not below the x-axis, g is above the x-axis. And so if you integrate, let's say f, and we'll say from a to b, that is going to find all of this area between the x-axis and the red curve f. And then we're going to subtract the integral from a to b of g of x, because if we just want the area S, which is between the two curves, we've already counted this part that's under G, so we don't need to count that. So we're going to subtract that off with this term here, and that gives us the total area S. And of course, properties of integration, we can split these functions up or put them together. These are going to be the same. So that's the idea. You can take two functions. If one is completely above the other, you can subtract them and get the area, and then integrate and then get the area between the curves. All right, so let's look at this example. And I believe on most of these on the homework, you're going to have a picture, which makes things easier. If you didn't have a picture, you could still do it, but then you got to know what the graph looks like, and sometimes that's not easy. So they keep this pretty easy for you and just give you the picture so that you can see exactly what you should be integrating, which functions on top or bottom. So we want to find the area between y equals e to the x and y equals x from x is 0 to x is 1. And so that is just going to be, and we'll just use a for this, the integral from 0 to 1. We have our top function is e to the x, and we have our bottom function is just x, and then we're just going to integrate this. And so these will be pretty easy as far as the integrating goes. We're not going to do anything too complex with integrating, so I won't spend too much time going over that. Again, I mean, we're still in the beginning of this course. If you're a little bit rusty on your integration, if it's been a few months or a year or however many years, maybe, go back and review some of the you could probably find a worksheet online that goes over basic integrals, or you could find a table and functions like x, e to the x, basic trig functions. Those will be in any table that you can find on the internet. All right, so now we'll plug in our limits of integration. So we have e to the first power minus 1/2 times 1 squared, and then minus, now we're going to subtract the lower limit, so e to the 0 minus 1/2 0 squared. And so we get e minus 1/2. E to the 0 is 1, and then this, of course, is 0. So we end up with e minus 3/2. Okay, so easy enough. This section is not going to be too difficult, I don't think. Next one, we have the area of this region, and you can see we have 2x minus x squared, and then we have x squared. And even though these are both curves, it doesn't matter as far as what we're doing. The main thing you want to make sure that you're paying attention to is working with the x part. And in this case, it goes 0 to 1 1, so you can't even make a mistake there. So we have the integral from 0 to 1. And then we're going to take the top function, which is the 2x minus x squared, minus the bottom function, which is just x squared dx. Simplify this, and then we'll integrate. So 2x minus 2x squared dx. Integrate 2x, we get x squared. Integrate 2x squared, we get 2/3 x cubed. 1 to 0. Plug in 1. And I probably won't do this where I plug it in and then simplify, because we could obviously see, we should see that this is just going to be 1 minus 2/3. But we'll plug this in for a couple of times in the beginning. As we go along the course and keep integrating, we may or may not do this. So 1 minus 2/3, those are both 0, and then we get 1/3. All right, nothing too difficult here. Now let's look at this next one. So here we have a different kind of curve. So these are not functions of x, these are functions of y. And so you can see you can't pick a value of x, whatever that might be, and a value of x here, because you don't want to count all of this area here. Additionally, these are not functions of x, so it doesn't make sense to write this in terms of x, just like the above examples were not functions of y, so we don't write them in terms of y. So in this case, these are functions of y, and so we're essentially going to do everything the same way, except we're going to write everything in terms of y. So in this case, this area would be the integral from c to d, and then instead of f of x minus g of x, the top function is f of y and the bottom function is g of y. So this is just going to be f of y minus g of y times dy. And so it's the same thing, it's just turned sideways. And so it looks a little bit different, but it's not really any more difficult. The only thing, and really, I mean, I was going to say the only tricky thing might be which is the upper limit and which is the lower limit. But of course, when we're on the y-axis, d in this case is greater than c, so that makes sense that we would put d up here. And then x is going positive, going up in this direction, so this one is the top function. So we're going to take f of y minus g of y. So no big deal. It looks a little bit different, but we'll have to get used to working with x's or y's depending on what our graph looks like. And especially when you get to calculus 3, that's a big deal, is changing variables and working with whichever variable is more convenient. So sometimes one is more convenient than others. Just depends on the problem. All right, so this last one is one where we have to work with y instead of x. And so we are going from, now remember in this case, we're working with y, so we need to look at the y coordinates of these intersections. So the area is going to be the integral from -2 to 4. And then we're going to take the top function, y plus 1, minus the bottom function, 1/2 y squared minus 3. And so let's simplify this before we integrate. So we get y, 1, this will be a plus 3, so we'll make that a plus 4, minus 1/2 y squared dy. So now we'll integrate, so we get 1/2 y squared plus 4y minus 1/6 y cubed for -2. Now in this case, it probably makes sense to plug these in and be careful about doing it. So we'll plug in the 4, and then we'll subtract where we plug in the 2, or the -2. And we'll simplify from here. So we get 1/2 times 16, that would be 8, plus 16. 64 over 6. May need to get my calculator out just to save us time. We get 4 times 2, so that'd be 2 minus 8, and then that's going to be -8 over times -1/6, so plus 4/3, and then we'll get the calculator and simplify this. So we get 18. Okay, so that's a basic idea. This is a very, very simple formula to remember, and it makes sense. So it's not even a complex formula that you need to memorize that doesn't seem to, may or may not look like what it should. This is a very, very quick section, very easy, I think. So, all right. If you have any questions, you can let me know.